So we're finding our sinusoidal transformations. We've got y equals a sine of bx plus c plus d, or y equals a cosine of bx plus c plus d. And then we're looking at how to find amplitude, period, phase shift, and the midline or the vertical shift. So amplitude is the absolute value of A. That's how we find the amplitudes, the absolute value of A. Normally, if I had a number in front of, like, let's say I had x squared and I threw a 2 in front, that would stretch it vertically, right? That would have the impact of stretching that out vertically. And so a vertical stretch is a similar impact on amplitude. So if I put a number, instead of like y equals sine x, if I have y equals 2 sine x, what's going to happen is it's going to stretch that sine curve. And so that sine curve is going to go not up to 1 or -1 anymore. It's going to go all the way up to 2 and then all the way down to -2. And so that amplitude, the amount from the top to the middle, is 2 in that case, and that would be your amplitude. Okay, but it is absolute value. And the reason it's absolute value is because I could have something like y equals -2 sine x. Now it still has a vertical stretch of 2. The negative out in front would just flip the graph. So it would flip it over. It would have an impact, but it would only stretch it by a factor of 2. Okay, so we would say the amplitude is +2. The amplitude should always be a positive value. The period for sine and cosine, it's not this for every single function, but the period for sine and cosine is 2 pi divided by b. The normal period, so the normal time it takes to get through an entire cycle of all of those values, is normally 2 pi. Okay, so whatever number is being multiplied by that x, you want to take 2 pi divided by that number, and that's going to give you your new period. Because what b does in that equation is it's a horizontal stretch or compression. So it can stretch it out or it can compress it. And so what that means is if it compresses it, you're going to get through that faster. Okay, so 2 pi over b is how we find our period. Phase shift is the equation most guys really struggle with, is -c over the absolute value of b. -c over the absolute value of b. I would put a star next to that one. That one is the one that most students struggle with because there's a lot of things to remember. There's a negative, there's 2 variables, there's absolute value, -c over the absolute value of b. To refresh your memory, if I was looking at like f of x equals x squared, we'll just go back to something we're pretty comfortable with. And I looked at how is that different from, like, let's say g of x equals x minus 2 squared. Can someone tell me how that second one moved? Like, how does g of x move from f of x? What would you have to do?
It would move to the right too, because the vertex is x minus h, and so h would be the x value for the vertex, and so
perfect. Yeah, exactly. Exactly right. So let's say I had y equals sine x versus y equals sine of x minus 2. What do you think would happen to that graph if I have an x minus 2 there? How would this one move?
Right too.
Right too. It's the exact same rule. Those rules that we were talking about, they work for everything. Okay. Now that's technically right or left movement is called a phase shift. So our phase shift would be +2 in that case. That would be our phase shift. Okay. So when it's asking you for phase shift, it's talking about how did it move left or right. That's a phase shift. And if you look at those letters, well, B is 1 in this case, and C is -2. So if we use that equation for phase shift, we would have phase shift is equal to -c over the absolute value of B. So you end up getting a +2, which means right 2. That's what that means. Okay, but you guys knew that without having to do a lot of that work. It gets more complicated if it's like sine of, 3x minus pi. That's when those more complicated ones, it's hard to think about how that moves. It's very helpful to use that equation -c over absolute value of b. Okay, Any questions on this one? On phase shift, what that finds, how to find it. I'm erasing all this stuff. Holler if you have a question. Okay. Our vertical shift is just D. That's the easiest one. That's the one guys like the most. You don't have to do everything. Like vertical shift or midline just means up or down. So our normal midline's at 0. So if I just gave you like y equals sine x, that means the middle of that graph is at 0. So this is what sine looks like, right? It goes exactly above that x-axis as it does below. If I gave you y equals x squared plus 1, that moves up 1, right? If I gave you sine x plus 1, that moves up 1. Same rules, no matter what your functions are. It really works the same way, okay? And so what we mean by a midline, so our vertical shift, we would say in that case would be up 1. And our midline, the impact that that would have would be now the center of that curve is at 1. So it goes like up to 2 and down to 0. And the midline would be 1. Does that make sense how that graph would move? Hopefully, yes. Okay. Questions on any of those ideas so far? We're going to go through some examples and we're going to find those 4 things. So amplitude, period, phase shift, and vertical shift. Okay. So here's an example. Go ahead and write this down. We have y equals 10 cosine of 2x plus 8. Now those 4 letters, A, B, C, and D, those 4 letters do not exactly correspond to amplitude, phase shift, vertical shift, and period. Okay, but they help us find them. What I think is helpful to start is to figure out what your A is, what your B is, what your C is, and what your D is, and then go through and figure out those equations. Okay, so John, what's my A in this case?
10.
Perfect. What's my B, John? We're going to stick with you for all of these ones. What's B?
2.
Perfect. What's C?
0.
Excellent. And D?
8.
8. Excellent job. Okay, so the first thing we're going to find is our amplitude. And I'm just going to write down all of them first. Amplitude, then we'll find the period. Then we'll find the phase shift. And I'm calling it vertical shift, but it would be exactly the same thing on this last one if I asked you to find the midline. Okay, so just be aware of that. Let's go to Sam Traster. Sam, what's the amplitude?
Absolute value of 10, which is just 10.
Fantastic job. Absolute value of 10, which is just 10. What's the period?
2 pi over 2, which is, if you divide it, it just becomes pi.
Fantastic job. What's our phase shift?
Looks negative, I guess negative 0 over, I guess, absolute value of 2, which is just 0.
Perfect. So what does that mean that I got a phase shift of 0, Sam?
It just doesn't move horizontally.
It doesn't move left or right. Okay. My period changed though. So there is a change in the horizontal portion, right? So my period was 2 pi and now my period is pi, which means it's going faster. Some guys like to think about it as faster. Like it gets through there in only half the time, right? So I can get through a whole cycle by the time I get to pi. Now, by the time I get to 2 pi, I had 2 full cycles there. Okay. A cycle meaning going through that entire thing each time. Okay, and then we've got one more vertical shift. Let's go to Sam. We'll just stay on you for this last one. What's our vertical shift?
Just 8.
Perfect. That's it. Okay, this is a lot of the questions I'm going to ask. Again, phase shift tends to be the hardest. In this one, our phase shift was just 0. Anytime you don't have a C, anytime it's not like X plus something inside of that parentheses, then your phase shift is just 0. Good. Okay, any questions on this problem? We're going to do another one. Okay, go ahead and write this down. This is y equals negative 3 sine of x over 5. Be careful with those fractions. And then minus 1. So we have y equals negative 3 sine of x over 5 minus 1. Again, I like to start writing down what my A, B, C, and D are. I'm going to show you some abbreviations that you can use for amplitude, period, phase shift, and vertical shift. So just like when we were doing the 4 things for rational functions, you guys might remember we just abbreviated like VA, HA. There's some abbreviations that we're going to specifically use for these as well. Okay, so for amplitude, we're going to use a capital A. And you can write amplitude next to it if you want, just so you don't forget, but these are going to be in the same order. Period is the weirdest abbreviation. Period is a T. That's actually what we use to represent period when we get into like physics and engineering and science and all that kind of stuff. We actually use T. So we're going to stick with T. It would be nice if it was a P, but it's not. It's T. Okay. Then phase shift is just PS and vertical shift is just VS. So everything's pretty obvious except for period. Period is T, capital T. It is wrong if you write a capital P. Okay. You cannot make up your own abbreviation. The abbreviation for period is T. Matthew Tanner, let's go through our lowercase a, b, c, d. So what would be our A, Matt?
-3.
Perfect. And our A is -3. Okay. Our amplitude might be different, but the A, the thing in that equation is -3. Again, that's going to have two impacts. The 3 is going to stretch it. Matt, what's the negative going to do?
Is it gonna flip it?
It's going to flip it, right? It's going to flip it over that x-axis. Exactly right. So we can't just ignore the negative, even though it doesn't necessarily come up in amplitude. Okay, what's our B, Matt?
1/5.
1/5. Good job. A lot of guys see that divide by 5 and they'll accidentally write down a B as 5. It is 1/5. It's whatever is being multiplied by that x. Okay, let's go to C. What's our C?
0.
And our D.
-1.
Excellent job. Okay, let's go to Ben. Ben, what's my amplitude, or how do I find it? Talk me through that.
The amplitude is the absolute value of A, so it's the absolute value of -3, which is 3.
Perfect. How about the period?
The period is 2 pi over B, so it's 2 pi over 1/5. And then that's the same thing as saying 2 pi times 5, which is 10 pi.
Excellent job. So in this one, my normal period is 2 pi. So I get through that normal curve in 2 pi. That's all it takes me. Now we're way stretched out. So it's going to go way slower. It's going to take all the way until we get to 10 pi to get to that same curve. Okay, so it's going to really stretch it out horizontally. How about our phase shift here? How do we find phase shift?
Phase shift is the -c over the absolute value of B. So it's -0 over the absolute value of 1/5. So that's just 0.
Perfect. Which means what when our phase shift is 0?
It means that it's not going to like shift right or left.
Yep, no left or right shift. So it didn't move left, it didn't move right. It did stretch out horizontally.
Yep.
It did stretch out vertically, but it didn't shift. Excellent job. And then how about our vertical shift?
The vertical shift is just D, so it's -1 or down.
Perfect. And that would mean it moved down 1, right? Or that our midline is at -1. There's one thing I just realized I need to adjust on our little list back here. The period should also be over absolute value of B. So both of those are an absolute value of B. So your B could be negative. If your B is negative, what happens is it flips it over the y-axis. You guys might remember those when we did exponentials. So if the B is negative, that would be a flip over the y-axis, but your period would still be that whatever positive number is. And your phase shift, again, is only affected left or right by the sign of C, not the sign of B, okay? And I mean S-I-G-N, like positive or negative. Okay, sorry, I wanted to adjust that. Hasn't come up yet anyways. All right, we're gonna do another one. Y equals -3, nope, sorry, reading. Negative cosine of 3x minus pi over 2 plus 7. So on your paper, I would like you to both by yourself totally try to find A, B, C, and D, and then amplitude, period, phase shift, vertical shift. Do all of that by yourself. I'm gonna give you maybe a little more than a minute. See what we come up with. I'm going to give you about another 30 seconds. See how far we get. Looks like most of you are still working. If you're near someone in my class, you can compare what you guys got before I call on you. All right, let's go to Dane. A, B, C, and D. What did you get for A?
-1.
Fantastic. That negative in front means -1 specifically. It doesn't just mean negative or 0. Okay, how about your B, Dane? What'd you get for B?
3.
Your C?
-π/2.
Good. Your C is -π/2. Don't lose that negative. I'll give myself a little more room for that D. And then what'd you get for D?
7.
Fantastic job. Okay, now what we're trying to find is our amplitude, our period. Again, that's a T, our phase shift, and then our vertical shift. We're finding each of those things. Let's go to Nico. Nico, what's your amplitude?
My amplitude was the absolute value of -1, which was 1.
Perfect. Nico, what's a normal amplitude for cosine?
Just 1.
Yeah, it's also 1, right? Like when our parent function is our just most basic graph, y equals cosine, we would also have an amplitude of 1. So since our amplitude is still 1, Nico, what does that mean?
It's so far a normal graph. Is that?
So very close. You're right that the amplitude isn't different from our normal graph. So there's no vertical stretch. It did not stretch out, up, or down, right? There's no stretch there. Now, it's not exactly our normal graph because there is one difference. What would the one difference be?
It's just flipped upside down.
Perfect. So it's our exact normal graph so far, just flipped over, right? That's it. Perfect job, Nico. So yeah, the amplitude didn't change, but it's not exactly the same. It did flip over, and we noticed that from our A. Excellent job. Let's go to Michael Fisher. Nope, just kidding. Let's go to Thomas. What's our period here, and how do you find it?
So you find period by doing 2π/b. Since b is 3, it would be 2π/3.
Okay, so what does that tell me has happened to my graph? If my period is now 2π divided by b. I've said this a couple times. My normal period is 2π. So that's the time it takes to get through an entire cycle. So what would it mean if our new period was 2π divided by 3?
So now it's shrunk.
It shrunk. Which way?
What do you mean by which way?
So we can have horizontal compression, or we can have
okay.
vertical compression.
Okay, so yeah, it would be horizontal because it's the period.
Exactly right. So we have a horizontal, like it's squished a little bit, right? It's squished horizontally. 2π/3 is less. So now it gets through there 3 times as fast as normal, essentially. Okay, or it takes a third of the time to get through an entire cycle. Excellent job. Let's go to Bobby. Bobby, how do we find phase shift?
Phase shift, you have -π/2
Excellent.
over absolute value of b, which is 3.
Okay, so we have -π/2 over 3. So that's the same as +π/2 times what, Bobby?
3. Or
So divide by 3 cannot be the same as times by 3.
so
Divide by 3
3
cannot be the same as times by 3. It would be times 1/3. Okay, so be careful on those fractions. Fractions tend to be confusing, especially when you only have one in the numerator or something like that. Okay, and so what's your phase shift here? What do you end up with?
You end up with π/6.
Okay, so we end up with a positive π/6. Bobby, what does that tell me about my actual graph? What did the graph do?
So the graph moves to the right π/6.
Exactly right. And I would write that down so you guys have an idea of what the actual graph is doing. Some of you will get very good at finding these values, but you forget what it actually means. So this one moved to the right by π/6. Fantastic job, Bobby. Okay, let's go on to Miles. Miles, what's my vertical shift?
It is 7.
It's 7. Perfect, Miles. What's that mean?
That it shifts up 7.
Up 7. Perfect. That's exactly right. Or the midline's at 7, right? Because those could mean the same thing, but you're exactly right. Any questions on any of these topics so far? Any questions?
Ms. Toshner,
Yes, sir.
I'm a little confused as to why it's right by pi over 6.
So our final answer was a positive answer, right? Our final answer was positive. And so when our final answer is positive, that means it moved to the right. If my final answer was negative, it would move to the left. But an easier way to sometimes think about this is going back to the original equation, right? If I gave you like y equals x minus 2 squared, we talked about this one, that actually also tells me it moved to the right by 2. The fact that the original thing was negative said it moved to the right by 2. So the fact that this is negative also tells me it moves to the right by 2.
Oh, I see. Because
That makes
I knew
sense.
that I knew that since it's negative, it goes to the right, but that doesn't mean that okay, I see.
So the final answer, since it goes to the right, will be like normal. So it will be positive. It will match
Gotcha.
whatever you're actually expecting. Thank you for asking that. That's a great
Thank
question.
you.
I'm sure many people have that. Okay, let's go on. Let's do another one. 8 cosine. This one's tricky. We've got a bunch of fractions in here. 8 cosine of x over 3 plus pi over 6 minus 5. I'm going to give you less time this time. I'll give you a minute and a half. We'll see how we do. Okay, go. And you're finding your amplitude, period, phase shift, and vertical shift after you find your A, B, C, and D. About 30 seconds left. Get as far as you can.
Ms. Toshner,
Yeah,
I have a question.
go ahead.
So since the b is always with the x, will the x and c ever be switched? Like, will ever be in parentheses pi over 6 plus x over 3?
Absolutely. Great question.
Okay.
Yes, it will. And so that's why it's really important to notice the sign of both of those, right? Because if it was like cosine, actually, like I think next week we're going to do somewhere, it's cosine of pi over 2 minus x. So yes, it will sometimes be switched. So your C would actually be the pi over 2. Your B would be negative 1.
Okay.
Great question. Does that make sense, Miles? So it's still, the B is still whatever's being multiplied by X. That's still what your B is. And then the C is like the other number inside those parentheses. Great question. Thanks, Miles. Okay, let's go on to Patrick. Patrick, what's my A?
8.
Your B.
B is 1/3.
Good. C.
Pi over 6.
D.
-5.
Fantastic. Now we're going to find our amplitude, our period, our phase shift, and our vertical shift. Let's go to Cooper. Cooper, what's your amplitude?
The amplitude is 8.
Fantastic. What does that mean, Cooper?
The amplitude is the distance from the midline and the maximum to minimum point.
Exactly. Distance from the midline to the max. So it looks like it got stretched vertically, right? So now the top is up here at 8 and the bottom's at -8 as opposed to 1 and -1. Excellent job. Okay, Landon, how about the period? How do we find period?
Period is 2 pi over 6. So then it's
Not quite. I'm
oh,
not
no,
sure
2
where you're getting 6.
I meant B. I meant B. I don't know why. I said
Okay. 2 pi over b. Cool.
2 pi over B. So that's
Okay.
2 pi over 1/3. So yeah. So then it's 2 pi times 3 over 1.
Good. So divide by 1/3 is the same as times 3. Okay.
Mhm.
And so what do you get here?
6 pi.
6 pi. So what did that change about my graph, Landon? How does that period being 6 pi make my graph different?
It doesn't it it's not the phase shift.
Yeah.
I know-
So what's the normal period of cosine, Landon? What's the normal time it takes to get through an entire cycle?
Is it 1 or what is
Nope.
it? I'm not sure. Is it 2?
So, nope. Make sure you're focused here. Looks like you're giggling and laughing. I'm seeing that. So that's what
All right.
happens. Okay. So normal period, look up here, is 2 pi. That's the normal time it takes to get through. Meaning I start here and I go through an entire cycle and I've gone 2 pi on my x-axis. That's the normal time it takes to get through that whole thing. So what we're saying now is now from start to finish, now it's 6 pi. So what would that do physically to this graph?
It would like stretch it.
Exactly right. And the way you showed that with your hands is right. So it's going to like horizontally stretch it, right? So now it's like going way slower. It gets all the way to that 6 pi. Great, great job. Okay, let's go on. Phase shift, and let's go to Ryan. Ryan, phase shift. How do we find that?
The phase shift is negative c over the absolute
Someone is unmuted besides Ryan, I think. Okay, sorry, go ahead.
the phase shift is negative c over the absolute value of b.
Okay.
And then I got pi over 6 over 1/3, the absolute value 1/3, which is then pi halves.
So what are you doing between that step and your final answer? So pi over 6 divided by 1/3 is the same as pi over 6 times what?
Times 3.
Perfect. And so then you get pi halves. What does that mean? What happened to that graph, Ryan?
That means it shrunk.
Nope, didn't shrink.
It compressed.
Nope, didn't compress. It's a phase shift. It's a phase shift. What do you think happened to that graph?
Oh, wait, no, that means it went. I think that means it went right.
It went right by how many?
Pi halves.
Perfect. Okay, questions? Yes.
Shouldn't it be negative pi halves?
Shouldn't it be negative pi halves? What do you think, Ryan?
Can you repeat that?
Yeah. Shouldn't this be negative, Ryan?
I don't think so.
Okay, read me your equation again really quick. What was your equation?
8.
Oops. No. Read me your equation for phase shift.
Oh, it was pi over 6 divided by the absolute value 1/3.
What does this say that I've boxed right here?
I forgot the negative.
There we go. Okay, so negative c over absolute value of b means negative c. Our c was pi over 6, so there should be a negative out in front here, which means it should be negative pi over 6 times 3, which should be negative pi over 2. So Ryan, how does this graph move?
Left pi halves.
Perfect. Left by pi over 2. Excellent, excellent job. Good catch. Okay, be careful of that negative there. Good work. Let's go to Jorge. Jorge, how about our vertical shift?
For the vertical shift, I have -5.
-5. Jorge, what does that mean? How did it move?
It went down 5 units.
Perfect. It went down by 5. Exactly right. So it went down by 5, or the midline is at -5. Those are the two ways to think about that. Any questions? Some of y'all in the Great Hall need to get focused here. You're missing out. Okay, make sure you're focused. All right, we're going to talk about some graphing. You guys did a lot of graphing practice on Friday, so hopefully you're okay with some of this stuff and what these graphs look like. All of this comes from our unit circle. So if you know your values on your unit circle, you're going to be fine thinking about these values here. And you'll notice these are just like our quadrantal angles. So these are the ones like on the axes. So these are the easier ones to think about. Okay, so take a second, write y equals cosine x. draw the plane that I've drawn. So go from all the way from negative pi over 2 to 5 pi over 2. We're just counting in steps of pi over 2. And we're going to draw what this graph looks like. And this is our parent function graph. So this is our original cosine graph for our parent function of cosine. I'm also going to label that we have up here at +1 and that we have down here at -1. I should have done that in black, so I'll do that. Okay, so we need to know certain values here. We need to know what cosine is when our angle is 0, what cosine is when our angle is pi over 2, etc. So, Dayton, what is cosine of 0 equal to? Cosine of 0.
1.
1, you're exactly right. And the reason for that, if you visualize your unit circle, the angle 0 is over here, and cosine means what's the x portion. So the x portion is 1 there, right? We get a +1 for the angle at 0. What is cosine of pi over 2, Aiden? So pi over 2 up here. What's cosine of pi over 2?
Cosine of pi over 2 is 0.
Correct. Excellent job, because the x value at pi over 2 would be 0. Let's go to Justin. What would cosine of pi be equal to? So now we're over here.
It'd be -1.
It would be -1. Fantastic. Let's keep going on to Julian. What about cosine of 3 pi over 2? So 3 pi over 2 is down here. We're wondering what's the x amount that I am when I'm on that negative y-axis. Julian, what would the cosine
would
of 3
that be
pi over 2
0?
Also 0. Fantastic. How about, let's go to Carter Smith, cosine of 2 pi. I think Carter's not in this class. Or is he? I can't remember. Ty, let's go to you. Cosine of 2 pi. Need to update my spinner
1.
app. Cosine of 2 pi is 1. Fantastic job. And then we've got 2 more, and these are coterminal angles. So what we've just graphed is on our unit circle, and we're going 1 out either way. Josh, cosine of 5 pi over 2 just means, okay, we're at 2 pi, and we're going to go another pi over 2. So it's coterminal to pi over 2. What would cosine of 5 pi over 2 be?
0?
Yep, you're exactly right. How about at negative pi over 2? So same idea, except we went the other way. What would negative pi over 2 be?
Also 0.
Also 0. Fantastic job. And so what this looks like, it doesn't look like a bunch of like jagged lines or triangles or absolute value. Should be a curve. So I should have a curved shape, okay, that goes and it connects each of these dots. And you'll see the maximum, the minimums, the phase shift, the vertical shift, right? All that stuff. So vertical shift would be 0. Amplitude would be 1. That's the center to the top. Okay. Our period, the normal period, how long it takes to get through an entire cycle, you'll notice it goes at the peak of 1 up here, and then it gets back to that peak of 1 at 2 pi. So our normal time it takes to get through an entire cosine curve is 2 pi. Okay, that's our parent function. So anything we do to that, it might squish it, it might stretch it, it might shift it, right? But this is our parent function for cosine. We're going to do the same thing with y equals sine x. So let's come up with our parent function. So again, draw a very similar thing. We're going from negative pi over 2 to 5 pi over 2. I would also label 1 and -1. So I want us to think about the sine values. So now we're thinking about our unit circle again, but we're thinking about all the y coordinates. So like think about how much is this y coordinate when I'm at 0? How much is the y coordinate when I'm at pi over 2? How much is the y coordinate when I'm at pi? See if you can fill out some of those. I'm going to call on some of you shortly. Elijah, let's start with you. So what's sine of 0 if we start at 0? What's sine of 0?
It would just be 0.
You are exactly right. How about sine of pi over 2, Elijah?
1.
Yep, great. How about sine of pi?
That would be -1.
Not quite. So pi, Elijah, is
Wait.
over here, right?
Pi.
So we
Yeah.
want the y component when we're on that negative x-axis
so
over there.
So that would just be 0.
Yep, perfect. How about at 3 pi over 2?
Um,
So that's down here. So that's on that
-1. -1.
-1. Perfect. Good. How about at 2 pi?
That would be 0.
Good, because again, it's the y component. What do you think the next value would be, Elijah? Just looking at that with the pattern.
Probably 1.
You're exactly right. And if I went on the other side, so at negative pi over 2, what do you think that value would be? Just looking at that pattern.
That would be 0.
So look over here at 0, we're already at 0. So what do you think it would be?
It'll go to 1. It'll go to 1.
You're close. Look at the pattern and how
-1?
that. There we go.
Oh, it's on the left side, so -1, yeah.
Because it's on the left side, exactly. So if we were to go, I think you were thinking like what would come next right here, that would have been 0. Yes, you would have been right. So I was trying to talk about at negative pi over 2. Great job. So now we're going to connect those. Again, that connects and makes a nice curve. So I shouldn't have any pointy edges. It should be just a nice curve here. We're connecting all those dots. Again, we could find all those other values in between, like the rad 2 over 2 or the rad 3 over 2. But generally, the 1s and -1s and 0s is the easiest things to think about. So that's what we're going to do with our parent function. Excellent job, Elijah. So this is sine, and this would continue. And that's kind of what Elijah was saying. Like if we kept going, that curve is going to keep going as well. It doesn't just end there. It's going to stretch or compress, okay? All right, let's do an actual example. So if I ask you to graph, I am secretly asking you to first find A, B, C, D. I am secretly asking you to then find amplitude, period, phase shift, vertical shift, and then translate all that information onto a graph. Okay, so we're taking this equation and we're going to translate all that information. So we first need to find our A, our B, our C, and our D. A in this case, let's go to, hopefully you guys have this written down. Adam, what's our A?
It's 1. I mean -1.
Careful, it's -1. Good. Remember that negative is going to have an impact. Adam, what impact does that negative have on our graph?
It reflects over the x-axis.
Fantastic job. It flips it over or reflects it over the x-axis. Adam, what's our B?
2.
And our C?
Negative pi over 2.
Good. And the D?
1.
Good. Excellent job. Okay, now we're going to find our amplitude, period, phase shift, and vertical shift. Let's go to Dayton. Dayton, what's our amplitude?
So it's the absolute value of -1, which is 1.
Good. What does that mean, Dayton?
The distance from the midline to the max point is 1.
Fantastic job. Cooper, how about our period?
Our period is 2 pi over the absolute value of 2, which is just equal to pi.
Good. What's that mean?
It means how many times until a y value is repeated going in the same direction.
Good. That's a good way to explain that. How many times the y value is repeated going in the same direction. So maybe how many times we see our max, like the separation between our maxes or the separation between our mins. That's a great way to think about that. Excellent job. Another thing also to notice is it's compressed, right? That would compress it because normally it's 2 pi is the whole thing. Now it's just pi. So it's going to get done in half the time. Ryan, what's our phase shift? It did actually call on you for phase shift again, just if you're wondering. Go ahead, Ryan.
It's -0, the absolute value of b, which is -pi abs over the absolute value of 2.
Ryan, It is negative C over B. What's our C?
Negative pi halves.
Okay, so it's negative.
Pi halves over the absolute value of 2.
Boy, come on. No way. What's incorrect about this?
I forgot to add in the negative.
Okay, so you are definitely not going to miss that when we take this next test because you've now forgotten it twice. So negative pi over 2 divided by our b, which is 2. Okay, so Ryan, keep solving that for us. So
which then you multiply it would then be a positive pi halves, then you multiply it by 2, which would then just be pi.
So hold on, divide by 2 is not the same as times by 2. Divide by 2 is the same as times by what?
Oh, yeah, so it would be, you then switch it to multiply by pi halves. Because like
so we have pi halves. I'm wondering, so you're saying divide by 2, that's the same as times what?
Times 1/2.
1/2, there you go. I think that's what you meant, but you said pi halves. Okay, so we have pi over 2 times 1/2, which is equal to what?
Pi over 4.
Okay, so what does that mean? How did our graph move?
That means that it's shifted right by pi over 4.
Perfect, exactly right. Great job. Okay, let's go to Oliver. Oliver, what's our vertical shift here?
1.
Perfect. What does that mean?
The whole graph moves up 1.
Whole graph moves up 1. Our midline's now at 1. Okay. All right. Now we're actually going to take that information. So we have an amplitude of 1. We have a period of pi. We have a phase shift of right by pi over 4. And then we have a vertical shift of 1. We're going to try to put all of that on a graph. Okay. So we start with our original function. We have our parent function, and we're going to do a bunch of different stuff to that. So again, our parent function looked like this, if we remember, right? This was like our parent function where each of these values we have shown here. And we're going to make some adjustments to that. Okay. So the period changed. So there's 2 ways I can adjust this. I'm actually going to erase this leftmost point and this rightmost point for now. The period changed so that the period is now pi, meaning it's going to get done in half the time. So instead of the midpoint of our graph being like pi, instead of going 0 pi and 2 pi, it's going to go twice as fast. And so one way we can deal with this is by changing this, all of these, to the equivalent values divided by 2. So if this was pi over 2, it would become pi over 4. This would become pi over 2. Oops, 2. 3 pi over 4. Pi, and then from there. All I did was take each of those original values and divide them by 2. Because that way my graph can look very similar, right? Like if I have my normal graph, it normally finishes by 2 pi. Now we would be able to finish. Oops. Did I have that drawn right? Pi over 4. Oh, that should be a 0. Like this. Right, so it gets through that entire curve by the time we get to pi. Okay, then we're going to shift it, and we're going to shift it right by pi over 4. So that's actually easier to do here as well. I'm just doing these with dots first, and then I'll connect them later. So if I take everything and I just shift everything right by pi over 4, now that my actual differences are in pi over 4, it makes it easier to do that. Okay. Now I'm going to move the whole thing up by 1. I'm just going to relabel this for now so that this would be 2, this would be 1, and then this would be 0. So actually my x-axis is here. And my midline is there. So my x-axis I've just moved to make it a little easier to see. Okay. Now that graph would look like this. And again, it would continue. However, there's one additional change that happens. I know the bell is ringing now. So we've got all of those 3 changes, our period, our phase shift, and our vertical shift. What's the final thing that actually changes about this graph? It's not in those 4 things. We talked about it though.
It
Anyone
flips
know?
over the x-axis, right?
Correct. It flips over the x-axis. So all that means is I got to take my final graph and I've got to flip it over. So each of those points just flips over the midline, essentially. That's where it flips. It really flips over the midline. Okay, all right, that's enough for today. We will pick this up tomorrow. You have you have Khan Academy due tonight on all of this stuff. Have a wonderful day. I'll stay on if anybody has questions.
Is this how you